Pressure is force over area. The dimension of force is MLT to the power negative 2 over area is L squared. So if area is L squared, then ML, this is 1 minus 2 e to the power negative 2. This will be equal to ML to the power negative 1 e to the power negative 2 becomes the dimension of pressure. The H derived units will be kilogram per meter per second squared. Before it was honored to Pascal. Testing.
Mr. Edward, please, I can't see where you're fixing everything.
Oh, okay. Let me adjust. I hope you can see now.
Yes, please. Thank you so much.
Oh, yeah. Kilogram per meter per second squared. This actually can also be written as kilogram meter second squared. Okay, kilogram per meter per second squared. So instead of bringing the minus 1 minus 2 up, you can also express it in this form. All right, so that answers the first part of the question. That you see, one of the first usage is that we can use dimensional analysis to determine SI unit of quantity. Okay, let me drop. Okay, before that, let me drop a question which came in one of the years working. If you are done writing what is at the far left, can I clean it or adjust the screen? All right. You are given this. F is equal to J M1 M2 over R squared, where F is equal to gravitational force please mute yourself, okay? If you haven't muted, do so for me. M1 and M2 are masses respectively. R is radius between the masses. And G is gravitational constant. Meaning I'm defining the variables within the equation. The question is that determine the unit of G. F is gravitational force. Gravitational force is a force. Gravitational force is a force. M1 and M2 are masses. They are masses. And R is the radius between the masses. J, we are told, is the gravitational constant. We have to determine the unit of J. Start with. Help me determine the unit of J. Okay. So just take a bite. And I think we'll look at it together. Start with.
BM, please mute your microphone. Mr. Adia, please, I can't see the screen because somebody has not muted.
You can see.
Yes, because somebody has not.
Really? I'm coming.
Please, it's okay now. Thank you.
All right. Hello. Have you finished? Okay. I think I'm sure you are true.
Yes.
Okay, then let's
Please.
discuss. All right. So how do we do this? So as we discuss it, please you mark yourself. Okay. The first way out is to make J the subject. So let's make J the subject. How do we make J the subject? I'll first think about eliminating the denominator. So I multiply through both sides of the equation by r squared. So I have f r squared equal to j times m1, m2 is simply m times m. So it's like m squared. Therefore, j will be equal to f r squared over what I see as m squared, because in fact it will be and they are m1, m2, and they are all masses. So the dimension will be simply m. So it's the same as m squared. Please, are we fine? Are we okay?
Yes, please.
All right. So I come to what's the dimension of f? F is a 4. Kelly,
Mr. Dorain, please go over again.
and all that we are doing is we are looking for the dimension of Jane. So we have to make Jane the subject. And how do? You think of eliminating all the quantities, okay, around Jane. So I multiply through by J, then divide through by, I have f r squared equal to m1, m2. So what I would have to do is divide through by m1 and m2. Gloria, why is your hand up?
Mr. Ada, please, what if when you are solving, can you do the substitution before you make J the subject? That
Oh,
is,
yes.
maybe you write the dimension for the F.
You can also do that, but you see, it's easier when you go by what I'm doing. Okay,
Yes.
so m1, m2. So I've made J the subject, and so we have to substitute the dimension. The dimension of force is m l t to the power negative 2. The dimension of the square of radius. Radius is a length, so L squared. And M1 is a mass, M2 is a mass. So divided by M squared. So I have M grouping of light ends, or you apply your indices. You apply indices here. This is to the power 1. So 1 minus 2. Okay. L to the power, this is 1, this is 2, 3. T to the power negative 2. So M minus 1, L to the power 3, T to the power 2. So this is actually the dimension of Jane. How many of you got this? How many of you got this? And if you got it, please just clap for yourself at home, at wherever you find yourself. Let me hear the clapping. Oh, okay. Yes, thanks for doing that. So let's come to the unit. This actually is the dimension. What about the unit? This is mass. So per kilogram, this is length, meter cube per second squared. Okay, which we can also express as meter cube over kilogram per second squared. So either you present the unit in this format or in the second form. If you have any question, quickly ask, and let's move on to the second one. No question. Good. The second use of dimensional analysis is that it is used to test the validity or the correctness. Lauren, quick.
Mr. Dear,
Hello. Lauren, go ahead. Oh, Lauren, time. Okay, let's continue. If he gets back to us,
Please.
I'll give you the chance to ask a question. The second use of dimensional analysis that it is used to test the validity or the correctness of a given equation. I'm giving you an equation. We have this equation V is equal to U plus AT. This is one of the equations of motion, where V is final velocity, U is initial velocity, A is acceleration, and T is time. Let's use dimensional analysis or information to test whether this equation is correct or wrong. And in doing that, you find the dimension of the left-hand side, expressions at the left-hand side. I mean, it must be equal to the dimension of the terms at the right-hand side. So left-hand side dimension must be equal to, let me put this in the square bracket to define dimension as we are discussing. So basically, what it means is that the dimension of the left-hand side must be equal to the dimension at the right-hand side. What is the dimension of the quantity at the left-hand side? Alexandra, what is the dimension of the quantity at the left-hand side?
Mr. Dear,
Yes, Alexandra.
it is LT negative 2.
Good, because that is velocity. So
LT negative 2.
LT negative what? Alexander, negative what?
1.
Negative 1. This must be equal to U is initial velocity, so LT to the power negative 1 plus what's the dimension of acceleration? Yaba?
Mr. Please.
The dimension of acceleration.
LT to the power negative 2.
So LT to the power negative 2. And then the dimension of time is T. So at the right hand side we have LT to the power, this is 1. Okay, so when we add, it's equal to negative 1. So this and this gives us 2 LT to the power negative 1. LT to the power negative 1. Now, the coefficient 2 is dimensionless. It's just a constant. But we look at the dimension at to the constant to judge whether the equation is dimensionally correct or not. And since LT to the power negative 1 at the right hand side is equal to LT to the power negative 1 at the left hand side, we conclude by saying that the equation is dimensionally correct. So Therefore, since LT to the power negative 1 at LHS is the same as dimension at the right hand side, equation or relation is dimensionally correct, or equation is valid. So either equation is dimensionally correct or it's valid. Please, are we fine?
Yes.
Yes, please.
Yes, please.
All right. I'm giving you a question which dropped in WASI 2021. If you are writing, quickly do so before I clean the board. Are you done writing?
Yes.
No.
Okay, then let me
Yes,
take
please.
I'm taking a shot and I'll post it on the platform so you take it from there, right?
Yes, please.
Yeah.
Okay, so the question is sent to the platform. Eresi, hello,
Mr. Dia,
uh,
Mr. Dia,
you just dropped something. What is it that you want to?
um, Mr. Dia, please, on the board, it says, LT minus 1 plus LT minus 1.
LT to the power negative 1.
Yes, to the power negative 1 plus LT to the power negative 1. Then we got LT to the power negative 1. I thought negative 1 plus negative 1 is equal to negative 2.
No. Yeah, okay, here you see, it's like adding, it's the same as having x plus x. LT to the power negative 1 is 1x, LT to the power negative 1 is another x, right? So when we add x to x, it is equal to 2x. So it's the same as what we had here.
Okay.
Are you okay?
Yes, please. Thank you very much.
Welcome. So I'm giving you 2 minutes. Quickly go through the question, then we come to it. Okay. Priscilla,
Mr. Ije, please, I wanted to ask that. So during addition and subtraction of these dimensional analysis, the powers are not affected.
no, the powers are affected, but you see, let me clear this side and then get that for you before we continue. Look at what we had, what we have over here. We have L to the power 1.
So please, I actually mean
T to the
like the last, let's say,
I'm
the
developing,
dimension itself.
I'm coming. I'm developing something, okay? So here we can add this to this so that we have L to the power T negative 1 plus, this is only L, but for T we have negative 2 plus 1, giving us negative 1, okay? This and this are equal or like 10, so we can add them. And so 2LT to the power negative 1 to LT to the power negative 1. Now, all that matters is that the dimensions must be the same, okay? So we overlook the constant or the coefficient here. And once we have same dimensions, we conclude that they are dimensionally correct. So have I answered your question?
Yes, please. Thank you, sir.
All right. Then let's look at the question given. And we are answering the first one. That a car travels a distance y in time t. If the car starts from rest and moves with a constant acceleration a, show that the expression y is equal to a t squared all over 2 is dimensionally correct. We are to show that y is equal to at squared all over 2 is dimensionally correct. I want you to try that. Since we solved a question and testing validity for validity, I want you to try, okay? Okay?
Sir, please, a question again.
The question is, Lizzie, the question is on the platform. I sent it to
Okay,
the,
please. Okay, please.
all right. So 2 minutes to look at it. Hello. Hello.
Hi.
Are we through? Are we through?
Yes, please.
Yes, please.
Is that valid?
Yes.
Is the equation dimensionally correct?
No.
No. Okay.
Yes, please.
Mami Boatma
Yes, please.
is dimensionally correct.
Mr. Edia,
Yes.
please, what I did, the equation is dimensionally incorrect.
Incorrect. We shall see. Don't worry. Okay. So let's solve it together.
Jesus.
Okay. So
Correct.
is equal to 8 squared all on 2. And you have to understand what y is. From the question, y is a distance. Okay. C is time, and A is acceleration. So what do you think will be the dimension of y? What will be the dimension?
L.
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 So the dimension of acceleration is L t to the power -2. The dimension of time is t squared. So we have all on 2. So we have L t -2 plus 2. All on 2. T -2 plus 2 is equal to 0. And what is t to the power 0?
1.
1. So what do we have? Half L. Is it dimensionally correct or incorrect?
Correct.
It's correct.
It's correct.
It's correct.
It's correct. Because I told you that the coefficient doesn't matter. That is dimensionless. It's known as a dimensionless constant. But what we use to get is a dimension. Is the dimension at the left-hand side equal to what is at the right-hand side? If yes, then equation is dimensionally valid or correct. All right. So that's it with how to use dimensional analysis to determine the validity of a given equation. Let's move on to the next item or the next use of dimensional analysis, and that is to derive an equation between two or more given quantities, right? So we'll begin that by a question. I'll solve one with you to see how we apply that in getting the equation. Let me send a short onto our platform, okay? That will save all of us from questions. Now the period of oscillation, please. What is a period of oscillation? The period of when a body is oscillating or a body is undergoing harmonic motion, the time taken for the body to make one complete oscillation. So if the motion starts from this point, okay, come to this point and then return, okay, from one extreme to another extreme and back. The time taken for the particle to do that is what we call as a period. Okay, so if the period of oscillation of a simple pendulum depends on the mass, so T is directly proportional to the mass. The same T is directly proportional to the length. So we have T also directly proportional to the length. And lastly, T is directly proportional to acceleration due to gravity. Okay, these three relationships explain direct proportionality. And when quantities have this sort of relationship, it means an increase in one would cause an increase in the other. So T depends on mass, T depends on